we learnt about simple loader or general loader, in which our source program will convert it into many object files. That depends on how many number of functions or classes it is having. So all those object files will be converted into one single executable file by the linker, and here linker only specify the starting address where should be load. For example, say 1000. Okay, it will say in that particular address it has to load, that will generate, and loader will load into that. So disadvantage is what? Still some part of the memory is occupied by the loader. Okay, so now to overcome this disadvantage, we go for one more type of loader called absolute loader, and this is the simplest loader. Okay, so absolute loader. So in this video we are going to discuss about what? Absolute loader. In this, what happens, our source program may contain many functions, subroutines, or classes, or methods, whatever we can call. Okay, now all those will be generated as an individual object files, but these object files are not going to make it as not going to link into one executable file. So that is the change here. Okay, now here it is not going to link by the linker. So every object file, whatever compiler generates, it will also generate some absolute address, also called as physical address. We call physical address because this is a physical memory, main memory. So in this we call physical address, logical address, physical address. I think you people heard that. Okay, so logical address means we use that word with respect to the secondary memory, whereas physical address we use with respect to what? Main memory. Since our assembler, okay, here instead of translator now we'll call what? Assembler. Assembler will convert our program written in high level language into multiple object files. It also specifies which address, okay, starting address. It generates the object code, and as well as it generates starting address. Starting address at the beginning of the object code. Okay, starting address. So okay, so that means whenever it creating the object file, it generates the object file, object code, and as well as the starting address, and it will insert the starting address at the beginning of every object code. Now this, and then here complete loader is also taken out from the main memory, and here we are nothing we are having. So now we are having main memory. Okay, now so it specifies the absolute address. For example says, okay, so it says starting address is equal to say for example 1000. This is some 2710, and this is say 3400. Now somewhere assume it start from 0, some for example something. So somewhere this is what? 1000, starting address 1000. Okay, then etc. Somewhere it is what? It is say 2710, and somewhere it is 3400. Now when it generates the what? When it generates the object code, it also specifies starting address and it will insert the beginning, and this object file, object code 1 will be stored on 3005. So here I will say now object code what? 1 will be stored here, and this the object code 2 will be stored in what? This address. So this is my object code 2, and this is my object code 3. So again here also, since here there is no concept of linking, no concept of relocation, and here allocation and translation both will be done by our what? Assembler. Okay, now so it will be stored in the 3500, so it will load here, and this will load here, and this will load here. This is what the loader. So this is what the absolute loader. So summary, in absolute loader, our source program will be converted, assembler will convert our source program written in high level language into multiple object files. Along with the object code what it generates, it also generates the starting address, absolute address, also called as physical address, and that address will be kept at the beginning of every object code, and in the space the same address need to load. This is now what is the problem here? So here we cannot do multi-programming or multitasking. We cannot execute more than one program at the same time. But today we are executing multiple programs at the same time. So why here there is no multi-program? So that's what the disadvantage. Okay. So disadvantage is what? No multi-programming. Why now multi-programming? Now you can ask her. Okay, why? I will explain. Now, whenever assembler, not this source program, as in after some time user wants to generate one more source program. For example, okay, let us say another source program 2, if I want to execute. Now, whenever it generates its object code, for example, let us take this also 3. It also says this will have to load at 3400, this has to load at 2710, this has to load at 3000. That means every time, whichever the program user execute, that program always will be loaded in the same address. Now, right now I am executing one program. After some time, I want to execute second program at the same time, parallel on. Now it will also generate the same program. That means now this object code is going to replace in this. That means this will be replaced by this object code. That means always any number of programs, whatever the programs, so it will give only that's what the absolutely the same address. In the same address it will overwrite. That means now second program object code will be replaced. Okay, will be going to shift in the first program object code. That means the previous program object code will be replaced by the new one. That means everyone, suppose now this is here. Now next one, now next program. Now this will work next program. That means the same place. So that means at any point of time we are having only one program. So that's why we don't have multi-programming concept at this point of program. Okay. So this is the disadvantage. One major disadvantage. Okay. Second disadvantage, since we need to store every time here only. Okay. Suppose assume now I use this program only. For example, I am using this program only. After few days or some days, assume we the coder, the developer, include one more new functionality. One more what? New functionality. One more new functionality means assume now for this object code. Now we added some 2-3 new functionalities. Now it will take some data and it will run. Now assume it will take some another 400 bytes. Another what? Some 700 bytes. Okay. Now 700 bytes. Now it will run. See, earlier assume 2700 to assume it is running up to 3100. We'll explain once again. Assume in this case this object code 2 is running from starting at 2710 to 3100. Now after adding new more functionality into the source program, it will run up to what? For example, run up to what? Say 400 bytes increases. Now 3100, so 300 means 3500. That means this program size will increases from 3100 to 3500, 400 extra. So now what is the problem? Now when it extends, see up to 3500, now to here it will now it is occupies. This one what? Object code only it occupies. Okay, it occupies object code 2 means this space of object code 1 will get replaced, overwritten. So that means this functionality we won't get. This is the major disadvantage of what absolute loader. Okay, so you people know what is the concept of absolute loader, what is the disadvantages. Okay, now what is the best example for this absolute loader? Means now you can say Bootstrap loader. Bootstrap loader is the best example of what? This absolute loader. Now I think everybody we know about this Bootstrap loader. Okay, or unknowingly we are using this type of loader. Now suppose assume our system is switched off. Now whenever we switch on, what happens? Which is the first program will run. The first program will run in our system as soon as we switch on is Bootstrap code. Bootstrap code. Initially that will be stored in what? Read-only memory. Our processor is directly connected to the read-only memory. Some hardware connection will be there. So as soon as we on the system, our CPU will get that code which is stored in the read-only memory, will get that code. What that code will do is there is a small code. That code will tells us where the operating system is loaded in the secondary memory. Okay, so now we know that this diagram I told many times. This is my secondary memory. We user always deals with what? Secondary memory, and we have main memory because CPU can take only either from main memory or can give main memory. But now to the CPU, I told now new thing. So read only memory is connected. So this is physical hardware. Now whenever our system is on, CPU will take the code from this bootstrap code from the read-only memory and take this address. Now the first one is loaded is what? Now, so this is my what? Main memory. So always it loads, assume zero address, 0, 1, 2, 3, like this addresses goes. Now from 0 to hexadecimal 0x79 up to this bootstrap code will be loaded. Now from the bootstrap code, that will be loaded into the main memory from the address 0 and it will run up to 79, hexadecimal number 79, and it will run. Once it runs, this code contains address where our operating system program is stored in the secondary memory. Now it will bring operating system. Now this code in the main memory brings operating system from the secondary memory load into this one. Now that will be started loading from the hexadecimal address 80. Now this operating system is loaded into that. Always compulsorily whenever we switch on, always whichever the system, our bootstrap code will be loaded into the same, this physical absolute address 0 only, and always our operating system, whichever the operating system in your system, that will be loaded exactly at the address hexadecimal 80 only. This is what the absolute loader, always it will load into the same address. Okay, hope you people understood what is the concept of absolute loader, advantage, disadvantage, and the one best example for absolute loader is bootstrap loader. Okay, so hope you people understood. If you have any questions, please write in the comments. Thank you. Thanks for watching.